All right. Hey, everybody. I'm going to do a pretty short one today talking about Athens. So last week on Thursday, I did actually my first ever remote meetup. So I did a presentation over Zoom, the Zoom video chat software, to a live audience sitting all in the same room in Portland. And I was in Chicago at the time, so it was a lot of fun to try that out. But anyway, I did it on the Athens project. So for those who don't know, I'm going to head over to the Athens project link here. Athens is a module proxy for the new Go module system. So Go modules is a new dependency manager introduced in Go 1.11, and it includes an HTTP protocol for downloading Go module code. And so Athens is a server with this fancy little logo here. And it's a server that implements that download protocol. So we're going to see that in action today. Everything from grabbing some new code to setting up the environment to doing a build and a test of the code. We're going to see all of that running against a real live Athens server that is on the live internet that you can use after today. So let's get started. I have this demo repository, and I will put the link to this in the show notes. And there's a huge README here. That's not too huge. It's long. It gives you sort of everything I'm going to say today in a lot more detail. And I'm going to cut through a lot of this and just talk about exactly what we're doing. Okay, so the first piece here, I've got my repo in VS Code. It's the same code that you can find on GitHub. And we have a really basic server using the Echo framework. So this is a fairly popular framework, especially for writing REST APIs. So I pretty much copied all the code from the Echo README. I just pasted it in here, and I still am using the code from the Portland Gopher meetup. PDX Gophers hashtag there. So I've got this all going. It's pretty straightforward, but you'll notice I don't have a vendor directory in here, and I don't have like a glide.yaml or a godep.toml file or any of the other dependency tracking files for the tools that we're familiar with. And I'm also not going to use go get to talk to stuff in the go path either. Okay, so the first thing, that's kind of the first point, is we're not in the Go path. So that's our Go path, a/go code, and we're on the desktop. Okay, so that's an important first piece here, is you don't need to be in the Go path when you're using Go modules, but there are some differences then in where the code comes from. Okay, so let's read on here. So we're going to go down here. And we're going to see here, this environment variable is what we need to use to turn on all the Go modules behavior. Okay, so in Go 1.11, it's off by default. And when we turn it on, behavior changes. Lots of behavior changes. I'm going to copy and paste that. Okay. And the second piece is, by default, when you run go get with Go modules turned on, go get still goes and grabs code from the VCS. It grabs it from GitHub or GitLab or whatever. We don't want that. We want it to grab from Athens. And there is an Athens running here at Microsoft Go proxy.azurewebsites.net. And since there's one running there, we can point the Go module system to it by setting this Go proxy environment variable. Okay, so I'm going to copy that and paste it in here. And now we've got our environment set up. Okay, so right now we could start doing go gets and go builds and everything else. Okay, but before we do that, we're going to clear caches. Okay, so just like before with the go path, sort of the go path go environment that we're all super used to by now, that was a cache for all of our packages that we wanted to use. But now that we don't have to be in the go path, there's a new cache, and this is a cache for our entire computer. So anywhere that there's a Go project that's using Go modules, the code for its dependencies will be under the Go path still, but this time it's going to be under /pkg/mod. So I'm actually going to blow away that cache. And I've got to sudo that because they're all in, all the files and directories in there are read-only. So I'm going to do that. I'll put in my password. And now the cache is empty. Great. So that means that now we're going to force everything to have a cache miss locally. And then it's going to go up and the Go module system is going to try to hit this. And this is the Athens server. So we're going to be live downloading code from the Athens server to satisfy our dependencies. Okay. So now I'm going to go and just do the final step here, which is as simple as this. Okay. So before I press enter on Go Build, I want to explain what's going to happen here. So the first thing that's going to happen is Go Build is going to go in and see one file, of course. It's going to see main.go. That's the only Go file in the current working directory. And it's going to find 3 dependencies. The first one is in the standard library, so it doesn't need to take any action. The second 2 here are external dependencies. So Go Build is then going to go and find these dependencies first in the local cache under pkg/mod. And then it's going to miss because there's nothing in there. And then it's going to go up to Athens and it's going to grab those and download them. And then after they're downloaded, it's going to put them into that global cache. And after they're in the global cache, then it's going to build this into a binary, just like it always does, except it's going to use the global cache for its dependencies rather than the Go path. Okay? So now I do the Go Build. You can see Go Build calculates everything it needs. Okay? And it actually did that from a file that I'll show in a second. So it calculates all the dependencies it needs. And that means the echo dependency and echo/middleware. That's these two. Okay, go back here. And it also calculates all of the echo dependencies. So that would be dependencies of dependencies. And then from there, it also calculated dependencies of dependencies of dependencies and all the way down. And those are all called transitive dependencies. Okay, so it had already calculated those and then it went to start downloading them. Now that happened pretty fast because I have a decent internet connection right now. But what's actually happening there is it's going up to the Athens server in the Azure, the Microsoft Azure, and it's going to grab the code. It's actually downloading the code over the real internet. And you can use the same server if you want. Anyone can use it, and you can do your Go gets and your Go builds against it. Okay? So the last piece. Go Build already knew all of the dependencies that it needed. But from code, it only really knew about one. So how did it know about the rest? And that we bring the Go mod file into the fray here. Okay, so I had already actually run Go Build before I did this demo. So the very first time you run Go Build and you have an empty go.mod file, Go Build is going to go into here and it's actually going to just download these 2 packages. Okay. Once it downloads those 2 packages, it's then going to analyze the imports in those packages. And when it analyzes those imports, it's going to see that those imports need dependencies as well. So it's going to have to download those as well. Right? So in this case, here's a real life example. We downloaded Echo, of course, and then it saw, oh, okay, well, we need this package called Gammon with a G. Okay, and it got that from the import path in Echo. So it found that, it downloaded Echo, it looked at the import path Gammon of Echo, and then it downloaded Gammon. And the same goes for all these other ones as well. So it downloaded the dependency, it figured out the dependency itself had a dependency, and then it downloaded that second level dependency, and once it had downloaded everything, meaning it walked the entire dependency graph and there was nothing left to get, it wrote down all the dependencies and the versions of those dependencies into the go.mod file. And now that it had that filled out, it no longer needed to do that analyzation. So it didn't have to go and download something and then parse it and then download the next thing and all the way down the chain. Instead, it just had that pre-cached, had all that analyzation pre-cached here. And when I did the Go build, it just read this file really quickly and issued all the download requests and got them back, stored all those downloads as modules into that global cache. Okay? So then just the last little piece here. It doesn't matter so much what the app does, but we're going to actually show it in action. Okay? So we've got an Echo server now running on port 1323. So let's curl that. 1323. There you go. So this is the actual binary we built. It says hi to the Portland Gophers. And that is pretty much it. Okay, so we have a really, really familiar interface, of course. But all the magic is behind Go build and Go get and Go everything else. Okay, so I will post, like I said before, I'll post all the details and the link to this demo repository. You can kind of check out some of the deeper details that I didn't get into today. I also talk a little bit about the workflow and how to use these new tools in your projects every day. And before I go today, I just want to mention that the Go proxy that I set this to is experimental. So it really does live on the live internet and you really can use it on your own machine. But it may go away and it may change over time. So definitely play around with it. Definitely give us feedback in the Athens repository, which is here. This will be in the show notes as well. So definitely try it out and give us feedback there. But don't rely on it in your CI/CD or your production workloads or anything else like that. Okay? So that's it for today. I hope to have you try out Athens, and I hope to hear from you about it as well. Take care, everybody.